Our next paper is be given by Thomas Holleczek from the SingTel. The title is Detecting Weak Public Transport Connection from a cell phone to public transport data.
Absolutely correct.
Please, now we need to set you up.
Yes, hello. So while we set up everything, maybe some words offline before we start with the presentation. So this paper I'm presenting is actually a collaboration between the MIT in Cambridge and SingTel. So I started off working on this project while still being a postdoc at MIT. And in the course of time I got an offer from SingTel to join them. And I couldn't resist, and now I relocated to Singapore and I'm working on the same stuff in Singapore. So my previous speaker, Simon, he's from Singapore, and most of you guys already went to Singapore, which I could learn yesterday when I talked to you in the post session. Singapore is a very efficient country, it's super modern, and I think the public transport system is probably the best in the world. It's super quick, super efficient, and still, people actually stop using it, right? So the Land Transport Authority, the public transport organization, found out that people stopped using the public transport system and shift over to cars and taxis. And these are the numbers. So back in 1997, about 63% of all people took public transport when moving around in the city. It went down to 58% in 2004, went down to 54% in 2008. And the question is why? What the Singapore government did was to send out agents that walk around and question people and families how they travel and where they travel with the public transport and with cars. But they don't have enough agents to do that, so they only question about 10,000 families. And this is how we come in. So we were wondering whether we can detect public transport and private car movements from cellphone data. Yeah, the study is pretty flawed that the government usually does because it only happens every 4 to 5 years, and only 1% of the houses are questioned, and there's a lot of spatial and temporal decisions over this. People just forget about where they travel when they fill out the form. And this is why we try to infer basically movements of people from cell phone data and public transport data. Now the data sets that we use are public transport data and cell phone data. So the cell phone data set that we're using is basically cell phone call data records of 4.5 million users in Singapore. So what is a cell phone call data record? So every time you use your cell phone connects to the tower, the closest cell tower, and it establishes a connection, and this is tracked by the SingTel base system, right? So the billing system of SingTel records every transaction that you make with your cell phone, and we record the location of your cell phone and additional information like who you call, who you text to, and it also happens when you receive a phone call, so it's on both sides of the communication. Singaporeans use cell phones a lot, so on average twice an hour, so we have an exact idea of where Singaporeans are at every point in time. And the market share that SingTel has is also very big, so it's about 50%, so we track every second person in Singapore, and also including roaming customers from abroad. Now the second data set we're using is public transport records. So when you move in Singapore, it's very similar to Beijing. You have a smart card, looks like this, like a normal card, and you check in and check out on every bus and on every train that you take. And we approached the Land Transport Authority in Singapore, and they shared data with us at the same period of time, so it covers 3 months of data. And they shared all transactions from the public transport system as well, so we know exactly which person checks in on a bus or on a train, and so all the buses, they have GPS on it, and we know we can track the locations of all buses pretty precisely. Now the question is, how do we combine these two data sets to find out where people drive in Singapore and where they take public transport? So an approach that is commonly used to measure people movements is a thing called origin-destination matrices. The transportation interested guys, if you might know it, but maybe not everyone, so I'll use it as an example. So suppose you have 3 regions in the city, R1, R2, and R3. Then an origin-destination matrix basically measures how many people commute between these 3 regions in a certain period of time. So suppose in, for example, 1 hour, X people travel within region R1, Y people travel from region R1 to R2, and Z people travel from region R1 to R3, then the origin-destination matrix looks like this. So the column basically indicates the origin districts, and the rows, the origin districts, and the columns, the destination districts. And You basically put just the number of people who travel between the regions inside the matrix. And the goal was basically to determine these matrices from cell phone records and public transport records. How do we do this? When you move around, you either, in Singapore at least, it's very hot, right? So you don't want to walk, you don't want to ride a bike, you don't want to take a motorbike, you either take a car or you take a public transport system. So a car can be a private car or a taxi. So when we measure trips between two districts, they're either public or private. The overall mobility can pretty well estimated from cell phone movements, so we capture everyone that moves. And the public transport records can be inferred from the public transport transactions from the system. And basically the subtraction between these two data sets, which is the red arrow here, tells us how many people travel with something else on the public transport system, which is people in cars and taxis. And that's what we're actually interested in, because this is the weak parts of a transport system. So everywhere where people drive and they don't take the public transport system is where usually congestion. Now, how do we do this? In the first step, we infer overall trips from cell phone records, and this is how we do it. So this is a map of Singapore. This is just a train line, so somehow the map doesn't show up anyway. And this is a quality record, so a person is around here. This is where the campus of the National University of Singapore is, but also you are not familiar with the map of Singapore. And there's a person that makes some phone calls, so we track him here at this location, and he starts to move around, and then the location stabilizes again in a very big residential area here at Serangoon in Singapore. And what we do is to basically apply a modified version of k-means to the consecutive location of a person, and we identify stable locations. And this is basically the start and end point of the trip. And what we do next is map these locations to districts, because we are interested in the movements between districts in Singapore. And in this particular case, a person moved from Clementi to Serangoon. So we do this every hour, so we determine when which person moves where in Singapore, whether they started trips and where they stop the trips. And in the end, we come up with something called an OD matrix, and this is a visualization of an OD matrix. So you see here in this diagram how many people travel between different districts in Singapore. So red lines indicate a very strong connectivity. Average connectivity is orange, and green is a weak connectivity. So you see here where in Singapore people travel with their cell phones. So you see there's lots of stuff happening here in the east, and also a bit of stuff happening in the west. Now we did the same thing with the public transport data set, and this is basically an OD matrix for the public transport system. So you see here, where in Singapore people use the public transport system. So you can already see some differences, right? So there's a bit less in the east, and a bit more stuff happening in the west, right? And by subtracting these two matrices from each other, you can infer how many people take something else in public transport, and that's the result. So this is where in Singapore people drive with a car. You see there's a lot more stuff happening in the east of Singapore, and pretty much nothing in the west. Now, this is a very rough estimation. We also looked at it in more detail. So this diagram here basically shows the number of trips made on the public transport and private transport system in the morning. So it's all the trips made between districts in Singapore between 6 a.m. and 10 a.m. Blue lines are people on the public transport system. Red lines are people on cars and taxis. So what you can see is that in the morning, people all stream towards the CBD area. So the central business district of Singapore is pretty much in the central south of Singapore. So this is where all the banks and insurance companies and other industry is located. And people usually live in the outside areas of Singapore. So in the morning, they all stream towards the central business district. And you can also see that in the east, there's a lot of more red lines, so more people in the east drive. And in the west, basically, people take more public transport. Now, in the evening, the situation is reversed. So people stream from the CBD area to their living areas. Now, a question for you. Maybe you can see it. Maybe the colors are too bad, but do you see a difference between this diagram and this one in terms of colors? So I'll go back again. This is in the morning, and this is in the evening. Any differences? Sorry?
At the bottom of the graph.
Yeah, there's more here. There's more. What you actually, there's a difference here. So there's more blue, right? So I'll go back. So here it's pretty much red. And when you look at the evening, it gets blue. But this tells us that in the evening, people take more public transportation than in the morning, and this is very interesting. So when you look at the exact figures, we found out that basically in the morning, 38% of all people travel with a public transport system, and in the evening, it's 52%. So how is this possible? So we investigated a bit, and apparently people tend to take taxis in the morning when they have the deadline. So in Singapore, the office hour is 8:30 to whatever. So you have to be in the office at 8:30. So when you have a deadline, you just take a taxi because you don't want to be late. Like I yesterday, I was way too late for the conference because I didn't take a taxi with the public transport system. So you don't want to rely on something insecure in the morning. And in the evening, you might go shopping, meet friends and stuff, and just chill out and take the train back because there's no deadline. And also people tend to share cars in the morning, right? Parents dropping off the kids at school, and people sharing cars with neighbors and stuff. The next interesting thing is that in the East, there's a lot of people traveling with cars. And this study is actually from 2011, 2012. So what's happening now is that the government, basically, they started to build a new metro line in Singapore, which runs exactly along this red line. So they figured out that there's a problem, and they are now opening up a new it's called the downtown line because it runs from the airport to the downtown area. And they're opening it up just now. So this problem will be solved in the next couple of years. Right, now conclusions. The flows of people between different districts and cities can be estimated from public transport records and cell phone quality records, and you can also determine the road share between different districts based on these data sets. Second, especially in Singapore, weak public transport connections are found in districts without train access. So when you don't have train access, you're more likely to take a car or a taxi because buses are not really nice to take because you have to wait outside, it's hot, you sweat, and people prefer using trains. And the third thing is that the mode share of public transportation increases with the time of the day. And so what the Singaporean government has done as well is to increase basically the prices in the evening and decrease the prices in the morning to push people into the public system in the morning. That's another measure to balance a bit the public transport budget. Right, the study is not perfect, so there's lots of limitations. First, the cell phones are not monitored continuously, so we only have records when you actually use your phone. This might be a problem, especially in the evening when you stay at home. So because you don't use your cell phone so much when you walk around. And the estimation of the location is also pretty flawed. So at the moment it's 400 meters. We're now working on pushing it down to maybe 150 meters by using triangulation, but it's far away from that. Right? So GPS is the location out of maybe 10 meters, 50 meters. So you can only basically roughly say where someone lives. You can't really pinpoint it down to a building or a block, but only within districts. Right. Thanks for your attention. I'm happy to answer your questions.
All right, now any questions, please?
Okay, I have two questions. The first one is that the public transport for people measured with the e-ticket and the cell phone together. But what if somebody just pay the cash and they just use the cell phone and just travel? Maybe that might be kind of public transport, but you just say it might be kind of the public that you just measure is a ticket. So that is the first question.
Okay,
The second one is how can from those data, how can you make a new service application? For example, I just came from Korea, and the Seoul government made a new route of bus transport by using cell phone, the trajectory, and they just made a new midnight bus after just measuring the people's using cell phone. So that might be kind of interesting to give the service for the kind of the citizen. So do you have any kind of interesting service for the application?
Okay, let's answer the first question first. People can only use the e-ticket, so you cannot pay in cash. So you always have to use this card here. So when you run out of money, you have to top it up. So there's no other way of buying other means of tickets. So you can only use this card. So we know every transaction that happens to the system, which is pretty good. The cell phone records only cover 50%, so we have to do an extrapolation and upscale. because we only have every second Singaporean, but it's spatially pretty well distributed. So we checked it with census data to make sure that there is no bias in the distribution of Singapore telecom customers. The second question, we're currently looking into the utilization of trains and the crowdedness of platforms. So as you know, the cell towers are located in different locations of a train station. So there are cell towers that are inside the tunnels, cell towers that are on the platform and different parts of the platform. So we're now trying to figure out how crowded the platforms are and in which areas there is more people than in others. So this might help to redesign basically the stations. And we can also find out in which part of a train there is too many people based on the cell phone data. So this might help people to choose basically the car of the train where they should get in. This is very recent stuff, so we discussed with the Public Transport Authority only last week. So we are working on this at the moment. But that's very interesting.
Next question, please.
Hey Thomas, and thanks for the great talk. And normally from my department, we really like to see the policy recommendation. Just that, and I agree with that lady that it's very interesting if the government would consider to maybe make a new route, public route for the people who travel under that pattern during the night. For example, with the location with a weak transportation pattern. And I have a question regarding the data. For example, normally when people make the calls and when they are traveling, there may be a handoff or handover pattern when they transfer the call from one cell tower to the other one. Have you considered this problem, or does it impact your results anyways? Because when people traveling, maybe the cell tower location changes, and maybe the result might be changed a little bit as well.
Yes. So in a telco, there's different data sources. One is a billing system. This is where actually your transactions are stored, and the second one is a location-based system. Right. This is the system that tracks your cell phone physically when you move and when there's handovers between stations and cell towers. This analysis is based on call data records which come from a billing system. So we only have information when you start a call, when you end a call. There's no handover information. If you want more precise information about basically the behavior between a call and all the handovers that happen, you have to take the data from a location-based system. So in our company, it's stored in different departments. And for us, it was easier in this case to only take the call data records from the billing system. So we are working on this. So at the moment, we also work with location-based services. So we have every handover information. So when your cell phone moves, it tries to connect to cell towers and you see handovers. And it also happens when you move and don't use it, right? So there is continuous tracking. So your cell phone always tries to connect to the closest cell tower. Because you can see this when you walk around in a city, you see the transmit, like the reception strength of the signal, and basically your cell phone always tries to optimize that.
Yeah. All right.
It's just stored in different systems, and some systems are easier to access.
Okay. Okay.
Thank you. I'd like to recommend gentlemen.
Thomas has have answered my question because, as I know, the location information can be found from the base station during the tower. But you have said you use the data set from the building system, so you do not use the location information from the base station.
Yes, the building system also records basically the idea of the cell tower.
I think the data from the building system is more convenient for you. Is that right?
No, the thing is that the building system doesn't store handover information. It stores the location of your call when you start it and when you end it, but it doesn't tell you what happens in between. When a customer complains, for example, we said, I didn't make this phone call, we have to be able to tell them, okay, you were here and you were here when you made the phone call. So we get information about the location as well. Well, it's only very rough estimation. There's no triangulation, so we don't triangulate the cell tower, it's just location of the cell tower. And in the city center, the range, like the service range of the cell tower is about 50 to 100 meters. So that's basically the location.
Thank you, Thomas. Let's give him a hand.